So first we see what are the problems or what are the types of concept that we study in clocks. So we first start with understanding the speed of the hands, the hour hand and the minute hand. Second hand will not cover it here. Then we see the problems on hands meet. When will the two hands of the clock will coincide? Such kind of problem. Then we see the problems where the angle between the two hands of the clock is 90 degree, 180 degree. So what is the time during that time? How many times it happens in 1 hour? And such kind of concepts related to angles. Then we see the problems where we find out the angle between the hands of the clock. So I'll give you any time and I'll ask you what is the angle between the hands of the clock at that time. So what is a method to do that? Problems on faulty clock, gaining clock, losing clock. Then normal clock with faulty clock working together. When will they show the same time again? Okay, so such kind of problem we'll deal with here. So let's start with first kind of problem where we study the speed of the hands. Okay, I need to find out the speed of two hands. So my convention here is the red hand that I am drawing it here. Okay, is a minute hand. And the blue hand is an hour hand. Okay, blue hand is an hour hand. Something like this. So that's what it is. So if I have to make 3 o'clock in the watch, what will I do? I'll put the minute hand here at 12 and I'll put the hour hand here at 3. So I know it is 3 o'clock in the watch. Now I am asking you, this is your minute hand, right? This minute hand, the red one, will come back to this position at 12 after how many minutes? Which means it will go something like this, right? It will go something like this and it will come back to this 12 after how many minutes? After how many minutes? So you will say 60 minutes. That's quite simple. In 60 minutes, it will come back to its position. Now, next question that I ask you here is, in this 60 minutes, what is the angle that is being traveled by this hand? What is this angle that I am talking about? This entire angle. What is this angle that is being traveled by this hand of the clock in 60 minutes? That is nothing but 360 degree. We can easily see it here. So what did I learn from this? This hand of the clock traveled 360 degree in how many minutes? In 60 minutes. So what is the speed? How much is it traveling? How much degree is it traveling per minute? So my answer comes out to be 6 degrees per minute. Okay, and that is now the speed of my minute hand. It travels 6 degrees in 1 minute. That's what I get from here. Okay, now similarly, as we found it out, it goes 360 degree in 60 minutes. Can you tell me about hour hand as well? This is an hour hand here, say at 12 now. Okay, this hour hand will come back to this position 12 after how many hours? After how many hours will it come back to this position 12? After 12 hours. Right, quite simple. It will take 12 hours to move the angle of 360 degree, right? So it also moved an angle of 360 degree. Okay, but in how many hours? 12 hours. So if you go 360 degree in 12 hours, how many are you moving per hour? 30 degree per hour. 30 degree per hour. Okay, now that is the speed of your hour hand. Okay, that is the speed of your hour hand. That is 30 degree per minute. And you already know the speed of your minute hand is nothing but 6 degrees per minute. Okay, now you can see it here. It is in terms of per minute. This is in terms of per hour. So we'll have to convert this per hour to per minute. Now even before we do that, we understand something from this. The hour hand goes 30 degree per hour, which means in 1 hour, if I go from 12 to 1 like this hour hand will move how much of degree? What is this degree? How much of degree? 30 degree. Okay, this makes me understand that in 1 hour there is 30 degree. So if I take 2 hours, 12 to 2, it will be 60 degree. If I take 3 hours, 12 to 3, if it is 3 o'clock in the watch, the angle between the two hands of the clock will be what? 90 degree. And that's what you have to understand it here as well. Okay, something that will be required in the next problem as we solve this. So between 2 hours there is a 30 degree. So now I know speed of the minute hand is 6 degree per minute. Speed of the hour hand is 30 degree per hour. So it goes 30 degree in 60 minutes, right? That is what is being said here. It goes 30 degree in 60 minutes. So how much degree it goes in 1 minute, which is quite clear, half degree per minute, half degree per minute. And that is the speed of your hour hand. So the speed of the hour hand is nothing but half degree per minute. Okay, that's what you have to get it from this part. So this two things I understood from here. Speed of the minute hand, 6 degrees per minute. It is faster, of course. And speed of the hour hand is nothing but half degree per minute. Okay, it is slower. It only moves half degree per minute. And the logic is quite simple. If I said it to you, it goes 60 degrees in 60 minutes, you would have said 1 degree per minute. But it is not going 60, it is going 30. So it is going half degree per minute. Okay, so that's what you have to understand. And if you have to just visualize this better with what we have studied in speed, how do you always write speed? In terms of meter per second, in terms of kilometer per hour, in terms of miles per hour, right? That's how you always write the speed. So how much does the vehicle goes in 1 second, 1 hour, or the 1 hour again here? Now I am asking you, how much does the hand moves in a minute, in 1 minute? Okay, and how is the hand moving? Hand is moving in a circle. Okay, so it will cover only degrees of distance. So the distance here is in terms of degree. That's what you have to understand. It's nothing but normal speed only, but the distance here is in terms of degree, because the hand of the clock is traveling across the circle. So distance has to be in terms of degree. Okay,